Let's go through LeetCode 240 search 2D matrix 2. For this question, it gives us an integer array matrix that is a two-dimensional array and a target. So it says that the integers in each row are sorted in ascending order from left to right. Integers in each column are sorted in ascending order from top to bottom. So trying to see if we have number target is in this matrix. So for this question, we will say there is a method like simulate the working. That means that we can choose initial step, which at a column at a row 0 and a column n-1 at the top right corner. So if this number is greater than target, then we'll see we're trying to keep running in two directions. Why we choose sit as the top right is that because we can choose either there is some way sometimes we need to get trying to get smaller. Sometimes we need to get larger to get we want to get a number as close as to target as we can. So we can also select the number on the left bottom and trying to go up and right? But if we put on the left up, go right or down, right? So it is keeping increasing, so that we don't have a way to keeping merge to the target. So, for example, we sit. So the process is that if we sit on the top right, so 15 is greater than target, we decrease our J index to 11. And we find that 11 is also here target 5 greater than target. Then we keep decreasing, and then we goes to 4. And then when 4 we find it's smaller, that means we need to increase the row, right? Increase row will increase number, decrease column will decrease the number. And here, for example, we find this number. It is already 5, right? Assume, for example, this is 6, right? In this case, we should get smaller, right? So it is keeping smaller and going 3, and it's small, and in this case, go to 10, right? And go out. So that we didn't find. So the process is keeping left and down, and try to go out of the bound. So if we find target, return true, otherwise return false. So doing like this will be n plus n time complexity, because it will be just two direction, left and down, right? So the worst case, it is going some kind of diagonal, right? And so it will be n plus n time complexity. So let's implement this approach in code. So we'll say int m equals matrix dot length, and n equals matrix 0 dot length, right? And initially we set I equals 0 and j equals n minus 1, right? So what we'll do is that while this kind of I is smaller than m, right? And j is greater equal to 0. So we'll say if matrix ij equals target, we return true. And if matrix ij is greater than target, then we should decrease the column with j minimus, right? Otherwise, we'll say else we're going to have I increased by 1, right? In the end, if we're going to out of the boundary, we just return false, right? So doing like this, it is O M O M plus n time complexity in the constant space complexity, right? But if for this question, if someone is asking, um, change change the criteria. For example, we say if n is much greater than m, how can we do that? So if this one is much greater than this, right? Apparently the m plus n doesn't have any optimizations. So that means that if we can get n to some kind of log approach, right, that will be much better. Um, so if log n, right? So what we think about is we binary search. So we binary search, for example, the first row, which is start will be index is 0. The end index is n minus 1, right? We binary search the last number greater, smaller equal to target. So we find a 4. And then this one is not 5. So what we do is go to next. And um and because we are increasing, right? Increasing this number, increases this number, we can binary search from 0 to this number, right? So every time we have this index, we binary search from 0 to this index plus 1, right? Because this one will always greater. This is the um, last index is smaller, right? So if we find 5 here, we find 5, right? So that means we find the result. Um, so doing like this, it will be and because we have need to iterate at most m rows, and for each row that is a log n operation. So for the case when m is very small but n is very big, we can the binary search on the row. But on the case if the rows are very big, right? So we can binary search vertically. So that and just iterate from left to right. That in that case it will be n log m operations, right? So so um so let's write code for this to implement this as well, right? So we know if the follow up is if n is much greater than m, how can we do? We should binary search on the row, right? So in that case, we're going to have int m equals matrix dot length and n equals matrix 0 dot length and equals n minus 1, right? And what we do is for int I equals 0, I smaller than m, uh, I plus plus. So let's see, we're going to have um, every time we are going to have this kind of end, right? Last smaller equal to, so end will be such last smaller equal to um we have a matrix, this kind of matrix I, right? And we start from 0 and we always start from 0, right? We end from, so the next row will be next row will be, let's say, we can set the next row instead of um instead of this kind of n plus one, we can set as n, right? The reason is that because it's keeping increasing, so the end will will not in the next row, it's impossible that it will go to the right, right? It can only be in that index smaller equal to current end. So we can have this one as end and target, right? So then we'll say if matrix I and equals target, then we're going to have return true, right? If we going out of the bound, we just return false. Going out of all rows. So probably we need a binary search last smaller equal to, right? So we have this row and we have have a target. Right? So in that case, we're going to have int n equals row dot length and start equals to 0. Then we'll have while start plus 1 is smaller than n. Then we're going to have int mid equals start plus and minus start divided by 2, right? And we'll say if row mid is greater than target, then we are going to we need to search on the left, so we're going to have n equals mid, right? Otherwise, we are going to have else we are going to uh, else going to have that start equals mid, right? So this ascending order, that means there is no two numbers are equal, right? If there is an equals, we should still search to the right, right? So does it say it has a number to be distinct? You see that it's the ascending order, right? So I assume ascending order that you do not have um if do not have the same number, right? So what we do is that we're going to have if row and is smaller than equal to target, then because we want to search the last return and otherwise otherwise mm, it says that this target so otherwise we just return start. Return start. I think return start is fine, right? Because if the start is still greater than target, we can return -1. But if, for example, if we have n equals -1, we can terminate early, right? And but the thing is that if we return start, that is we didn't find. That means this is always the first one, and the first element doesn't equal target. It will keeping going down, right, until going out of the bounds. So return start should be fine as well. Otherwise, you can write if this one equals -1, just return false. So doing like this, the time complexity will be n m log n time complexity. I'm going to write Python code using the let me see the m plus n complexity one, which is having two pointers. So we are going to have just simulate the move n equals the length matrix, and this will be length of matrix 0. Then what we do is that I'm going to have it sit either on the top right or left bottom equals 0 and minus 1, right? So we'll say while this I is smaller than m and j is greater equal to 0. So if matrix I, j equals the target, then we return true. And we write if matrix I, j, if this one is smaller than target, then we're going to have we're going to increase the row I should plus equal to 1, right? And we'll say else we'll have j should minus equal to 1, right? So in the end, we just, if we didn't find it, just return false.